Hello everyone, today we are going to formulate a differential equation from a problem statement and to solve that particular equation. Now this time it's involving industrial water tanks. So in fabricating one of such tanks, a customer wants water to flow into a rectangular tank with a horizontal base A. Now good practice over here is to simply draw out a quick sketch of the tank. Now water flows in at a constant rate of n units of volume per unit time. The water should flow out from the bottom of the tank through a hole at a rate proportional to the square root of the depth of water of the tank. And it's required that when the depth of water is h, the level of water in the tank remains constant. So we are to obtain a differential equation involving the depth x at time t. Now we can actually see a relationship over here between the volume of water with respect to time. So let V be the volume of water in the tank. Now the rate of change of volume of water is simply the rate at which water is added to the tank, which is a constant rate n, and we need to take into account the rate of water lost from the tank, which is proportional to the square root of the depth of water in a tank. And this is given by k root x, where k is simply a scalar factor. Now V is simply the horizontal base multiplied by the depth of water, which can be written as ax. Now since the area is a constant, we can extract a from this term, giving us this expression over here, which is a dx over dt equals to n minus k root x. Now in order to find k when x is equals to h, dx over dt is equals to 0, as can be observed from this statement over here. Now therefore, if we could substitute this into the expression here, k is equals to n over root h. Now therefore, a dx over dt is equals to n minus k square root h, and this will give us dx over dt n over a 1 minus root x over h, and this can be done by simply substituting k equals to n over root h into the expression over here. So this is the answer for part 1. Now for part 2, it is known that the tank is filled to a depth of 4h initially. By using the substitution x is equals to hu squared, show that u satisfies this differential equation over here. Now in such scenarios where the technique of substitution is used in a differential equation related question, always first differentiate the given substitution as the number 1 step, which is in this case 2hu multiplied by du over dt. Now this is an implicit differentiation with respect to t, so we need to add in this du over dt term over here. Next, replace dx over dt with this expression and replace all the x that you see in this expression with hu squared. Now by simplifying and rearranging the equation, we will have 2hua du over dt equals to n minus nu. And we are pretty close to what we are about to show right now. And this on the right hand side is equals to minus nu minus 1 by factorizing minus n away. And by bringing n to the left-hand side of the equation, we have 2ah over n du over dt is equals to minus u minus 1 over u. And we have successfully shown that it satisfies the differential equation as given in part 2 of the question. Now moving on to part 3, by solving this differential equation, find in terms of a, h, and n again, the time needed for the depth to reach 16 over 9h, and describe how x varies with t. Now the parts in all these questions generally guides you towards the final answer. Now making use of this statement over here, let's bring all the terms of u on the left hand side and the constants to the right hand side of the equation. Using the separation of variables technique, we will then integrate both sides immediately. So this term over here is actually an improper fraction, which can be split into 1 plus 1 over u minus 1. Now integrating this with respect to u, we have u plus ln u minus 1. And on the right hand side, and we simply have minus n over 2ah t plus c, because this is an indefinite integral and c represents an arbitrary constant. Now to get the value of c, not to worry, it's always found from the information in the question. Now initially the depth of the water is 4h, so when t is equals to 0, x is equals to 4h, and u will be equals to 2. And therefore c is equals to 2. Now it is also given in the question that we need to find the time needed for the depth to reach 16 over 9h. So when x is equals to 16 over 9h, u is equals to 4 over 3. And by substituting that into the expression over here, we have 4 over 3 plus ln 1/3 is equals to minus n over 2ah t plus 2. Now all we need to do is to make t the subject, and by rearranging the equation and making t the subject, we have 2ah over n multiplied by 2 over 3 plus ln 3. So this is the time needed for the depth to reach 16 over 9h. Now to describe how x varies with t, so as t increases, x decreases and approaches a depth of h. Now I do hope you have learned something from this video on how to formulate a differential equation from a problem statement. And if you have any questions or comments, do leave them down in the comments box below. And thank you so much for watching.